In this example, we'll begin with h of z and we'll then find the difference equation. So let us see how. H of z is given by this positive powers of z, the numerator over the denominator. This is different from our previous examples where we have shown that the equations would typically result in negative powers of z here. Therefore, we need to convert the representation of positive powers of z into negative powers of z. So to do that, we simply multiply the top and bottom by z cubed to the power of minus 3. The reason is that so that the highest power will become power 0. So in the denominator, when we multiply with z to the power of minus 3, we end up with this equation over here. So z to the power of 3 times z minus 3 is of course 1, 2z squared times z to the power of minus 3 is 2z minus 1, and so on. So the last one is 2z minus 3. Similarly, on top, we have z squared minus 5z plus 6 multiplied by z minus 3, we get this expression over here. So this is the form that we are familiar with, and now we can write y of z over x of z. So we can bring the equations up and we exchange, and therefore now we are almost there, and we can now get these two expressions and perform inverse z transform. So what did we just do? 1 times yz is 1 times yz, and we perform inverse z transform is simply 1 times yn. 2z minus 1 times yz, 2z minus 1 times yz is simply 2, and z minus 1 times z minus 1 times yz inverse z transform is simply yn minus 1. Second one is z minus 2, so this is z minus 2 yz. Of course, this is 1 times y of n minus 2. So term by term, we just use the same property as we did in the last slide. And we have done with the y's. Same to do with the x. We are using z minus 1 here times xz. So z minus 1 times x of z. The inverse z transform is simply x of n minus 1. 5z minus 2 times x of z. The inverse z transform is simply 5x of n minus 2. So you can just use this simple property also on the x, and this is the difference equation. In the exams and in the tests, what we typically do is that we'll either give you the difference equation and ask you to find h of z, so from here to here, or now in this question it's from here to here. Okay, thank you.